So this animal here has got a brain about the size of a grain of rice, and yet it can do things that you and I couldn't possibly entertain the idea of doing. And basically, it's all evolved to handle its food source, which is dung. So the question is, where do we start this story? And it seems appropriate to start at the end, because this is a waste product that comes out of other animals, but it still contains nutrients, and there are sufficient nutrients in there for dung beetles basically to make a living. And so dung beetles eat dung, and their larvae are also dung feeders. They are grown completely in a ball of dung. Within South Africa, we've got about 800 species of dung beetles. In Africa, we've got 2,000 species of dung beetles. And in the world, we have about 6,000 species of dung beetles. So according to dung beetles, dung is pretty good. But unless you're prepared to get dung under your fingernails and root through the dung itself, you'll never see 90% of the dung beetle species, because they go directly into the dung, straight down below it, and then they shuttle back and forth between the dung at the soil surface and a nest they make underground. So the question is how do they deal with this material? And most dung beetles actually wrap it into a package of some sort. 10% of the species actually make a ball. And this ball, they roll away from the dung source, usually bury it at a remote place away from the dung source, and they have a very particular behaviour by which they are able to roll their balls. So this is a very proud owner of a beautiful dung ball. You can see it's a male because he's got a little hair on the back of his leg there, and he's clearly very pleased about what he's sitting on there. And then he's about to become a victim of a vicious smash and grab. And this is a clear indication that this is a valuable resource. And so valuable resources have to be looked after and guarded in a particular way. And we think the reason they roll the balls away is because of this, because of the competition that is involved in getting hold of that dung. So this dung pat was actually, well, it was a dung pat 15 minutes before this photograph was taken, and we think it's the intense competition that makes the beetles so well adapted to rolling balls of dung. So what you've got to imagine here is this animal here moving across the African veldt. Its head is down, it's walking backwards. It's the most bizarre way to actually transport your food in any particular direction. And at the same time, it's got to deal with the heat. This is Africa. It's hot. So what I want to share with you now are some of the experiments that myself and my colleagues have used to investigate how dung beetles deal with these problems. So watch this beetle, and there's two things that I would like you to be aware of. The first is how it deals with this obstacle that we've put in its way. See, it does a little dance. And then it carries on in exactly the same direction that it took in the first place. Little dance, and then heads off in a particular direction. So clearly, this animal knows where it's going, and it knows where it wants to go. And that's a very, very important thing. Because if you think about it, you're at the dung pile, you've got this great big pie that you want to get away from everybody else, and the quickest way to do it is in a straight line. So we gave them some more tasks to deal with, and what we did here is we turned the world under their feet. And watch its response. So this animal has actually had the whole world turn under its feet. It's turned by 90 degrees, but it doesn't flinch. It knows exactly where it wants to go, and it heads off in that particular direction. So our next question then was, how are they doing this? What are they doing? And there was a cue that was available to us, was that every now and then they climb on top of the ball and they take a look at the world around them. And what do you think they could be looking at as they climb on top of the ball? What are the obvious cues that this animal could use to direct its movement? And the most obvious one is to look at the sky. And so we thought, now what could they be looking at in the sky? And the obvious thing to look at is the sun. So, a classic experiment here, in that what we did is we moved the sun. what we're going to do now is shade the sun with a board and then move the sun with a mirror to a completely different position. And look at what the beetle does. It does a little double dance, and then it heads back in exactly the same direction it went in the first place. What happens now? So clearly they're looking at the sun. The sun is a very important cue in the sky for them. The thing is, the sun is not always available to you, because at sunset it disappears below the horizon. What is happening in the sky here is that there's a great big pattern of polarized light in the sky that you and I can't see. It's the way our eyes are built. But the sun is at the horizon over here, and we know that when the sun is at the horizon, say it's over on this side, there is a north-south, a huge pathway across the sky of polarized light that we can't see, but the beetles can see it. So, how do we test that? Well, that's easy. What we do is we get a great big polarization filter, pop the beetle underneath it, and the filter is at right angles to the polarization pattern of the sky. The beetle comes out from underneath the filter, and it does a right-hand turn, because it comes back under the sky that it was originally orientated to, and then reorientates itself back to the direction it was originally going in. So obviously, beetles can see polarized light. Okay, so what we've got so far is what are beetles doing? They're rolling balls. How are they doing it? Well, they're rolling them in a straight line. How are they maintaining it in a particular straight line? Well, they're looking at celestial cues in the sky, some of which you and I can't see. But how do they pick up those celestial cues? That was what was of interest to us next. And it was this particular little behavior, the dance, that we thought was important, because look, it takes a pause every now and then heads off in the direction that it wants to go in. So, what are they doing when they do this dance? How far can we push them before they will reorientate themselves? And in this experiment here, what we did was we forced them into a channel, and you can see he wasn't particularly forced into this particular channel, and we gradually displaced the beetle by 180 degrees until this individual ends up going in exactly the opposite direction that it wanted to go in the first place. And let's see what his reaction is, because he's headed through 90 degrees here, and now he's going to, when he ends up down here, he's going to be 180 degrees in the wrong direction, and see what his response is. Does a little dance, and turns around and heads back in. He knows exactly where he's going, he knows exactly what the problem is, and he knows exactly how to deal with it. And the dance is this transition behavior that allows them to reorientate themselves. So, that's the dance. But after spending many years sitting in the African bush, watching dung beetles on nice hot days, we noticed that there was another behavior associated with the dance behavior. Every now and then, when they climb on top of the ball, they wipe their face. And you see them do it again. Now we thought, now what could be going on here? But clearly the ground is very hot, and when the ground is hot, they dance more often. And when they do this particular dance, they wipe the bottom of their face. And we thought that it could be a thermoregulatory behavior. We thought that maybe what they're doing is trying to get off the hot soil and also spitting onto their face to cool their head down. So what we did was design a couple of arenas. One was hot, one was cold. We shaded this one, we left that one hot. And then what we did was we filmed them with a thermal camera. So what you're looking at here is a heat image of the system. And what you can see here emerging from the poo is a cool dung ball. So the truth is, if you look at the temperature over here, dung is cool.